Hello and welcome everyone to online classes at Career Developers. Today we are going to learn matrices, an important topic in Class 10 ICSE, Chapter 9. I will not waste your time much in discussion. Let's directly hit the topic and try and understand, and let's decode what a matrix is. Here you can see I have written the topic matrices. What is matrices? What are matrices? Actually, this is plural of the word matrix. What is matrix? And we can know a matrix is a rectangular arrangement of numbers. A matrix is a rectangular arrangement of numbers. But how do we write these numbers? We write them into rows and columns. So once again, a matrix is a rectangular arrangement of numbers into rows and columns. And the plural form of matrix, the word matrix, is matrices. So when we are dealing with more than one matrix, we call it matrices. That's a plural form of the word matrix. Now, the next thing that we are going to understand is order, dimension or size of the matrix. Order of matrices. We can also call it dimension or size. Order of a matrix or dimension or size. We can also call the matrix order by these terms as well. What do we mean by the order of a matrix? What do we mean by the order of the matrix or dimension or size? With m rows and n columns, will be called a matrix of the order m cross n. So in order to simplify this, I will just say that if in a matrix we have m rows and n columns, then the matrix is said to be of m cross n order. This is a very simple concept. So we can also call it, what is the dimension of the matrix? For example, if I write a matrix, we denote a matrix by an uppercase letter, let's say A here, and let me write some numbers down, 1, 2, 3, 4, 5, 6, 0 and 8. Now you can see this is 1, 2, 3, 4, 5, 6, 0, 8. If I have to see this, I'll have to focus on 1, 2, 3, 4. These are written in a row. So I can call it row 1. I have another row here. I can call it row 2. Likewise, these numbers 5, 1 and 5, they are in a column. We can call it column 1. We can call it column 2. This I can call as column 3. And this one right here is column 4. Now, if I have to determine what is the order of this matrix, then I can call it, since it has row 1 and row 2, which makes it 2 rows and 1, 2, 3, 4. You have 4 columns. Now these are 2 rows and 4 columns. So when we say about the dimension or the size of the matrix A here, we will call it, it has 2 rows and 4 columns. As I was saying, this matrix A has 2 rows and 4 columns. I was writing it here down. 2 rows and 4 columns. So I can call the order of this matrix A, or we can say the dimension or the size of this matrix A as 2 cross 4. Like here in the definition we have written, if a matrix has m rows and n columns, the order of the matrix becomes m cross n. Similarly, here we can say the order of this matrix A is, because it has 2 rows and 4 columns, is 2 into 4 or 2 cross 4. I hope you have understood what is meant by the order of the matrix or dimension of the matrix, or we can also call it size of the matrix. Moving on. You can clearly see that when I have written an example of a matrix here, in this matrix I have written numbers like here 1, 2, 3, 4, 5, 6, 0 and 8. Since these are written in rows and columns, you can clearly understand that this is a matrix. Now let's get back to the definition of matrices again. Like, what's a matrix? A matrix is a rectangular arrangement of numbers into rows and columns. Now, why have I called it rectangular arrangement of numbers? Because you can see clearly, when you see this array of numbers, this arrangement of numbers, it has more number of columns than the number of rows. So you can clearly see that the number of columns is more, and that's why it is more on the length side, less on the width. And likewise you can see it in the rectangle. Even this looks like a rectangle. This arrangement of numbers looks like a rectangle. Now we'll come back to this again, but let's focus on these numbers here. What do we call these numbers? Yes, these numbers do have a name and we call them elements. We call them elements of a matrix. We can also call them by numbers. We can also call them by entries. Or we can also call it like components. So elements, numbers, entries or components. So these are the numbers, entries or components which actually forms a matrix. A matrix is nothing but an arrangement of numbers. But if you go by the history and if you want to know more about matrices, I can tell you a little here that matrix is actually a word that comes from a word mater. Mater actually means mother. The literal translation in English of this word mater is mother. And if I tell you what is the meaning of the word matrix, matrix actually means a room. And likewise, many children can come from one womb. Likewise, many types of determinants can come from a matrix. This is something that you will study in higher classes. But for now, I can only tell you that from one matrix we can have multiple determinants. This has application in almost every field of science and mathematics, including geography and physics. Especially this has direct implication, or you can say application, in the linear algebra, or you can say solving problems of linear algebra. You can directly apply matrices. For graphing and other system, we can also go for matrices, and the concept is applied there as well. Next we are going to study is types of matrices. So here 1, 2, 3, 4, 5, 6, 0 and 8, these are called elements, components, numbers, members, entries of a matrix. Now we come back to the main thing here, types of matrices. Types. Let's discuss the types of the matrices in detail. First, let me write a matrix here. As I have already told, matrices are represented by uppercase or capital letters. I'm writing here again with A. And here I'm writing a matrix. You can see 1, 2, 1 and 3. If I ask you what is the order of this matrix, you can clearly tell me that this has only one row. So it has one row, but if each number is considered a column, 1, 2, 3, 4, it has 4 columns. But when you see this matrix clearly, you just have a sense of a row. This matrix is called a horizontal matrix, or it is also called row matrix. So you can see here, it's a row matrix. It's just a row. So this type of a matrix is called row matrix. If I simplify and define what is row matrix for you, a matrix that has just one row. You clearly see the example written above, and then you can understand what is a row matrix. Likewise, we have another type of matrix which you can easily guess. Here I am using the letter B to denote the matrix. 1, 2, 1, 3. Let's say the entries are same, but if I ask you what is the order of this matrix, you can tell me that this matrix clearly is having one column. But if I consider 1, 2, 3, 1, 2, 1 and 3, each component or each entry as a row, then it has 4 rows and only one column. So now you can see here, this is looking like a column. So we call it column matrix. We also name it as vertical matrix. Now in this, you can clearly see there are 4 components which are written here as 4 rows, and one component which makes and determines even the shape of this arrangement is just one column, and that's why we call it a column matrix. So if I have to define, you can just make certain changes here, like what's a row matrix, you can just make some addition. It is column matrix. So what is a column matrix? A matrix that has just one column. Just one column. A matrix that has just one column is called a column matrix or a vertical matrix. Another type of matrix that you have to do is this. Which is a square matrix. Again, I have not erased the definition of matrices on top because I have not discussed what is a square matrix. As the name suggests, it has to have the shape of a square. And in a matrix, to give it a shape of a square, we have to keep one thing intact. And that very thing is the number of rows and columns. If we keep the number of rows and columns equal, then we will have a square matrix. For example, what's a square matrix? Let's go by the definition. A matrix is said to be a square matrix if it has equal number of rows and columns. A matrix is said to be square matrix, is said to be a square matrix if it has equal number of rows and columns. Let's see an example. Let's name it again with letter A. And if I write numbers like 1, 2, 3, 1, 0, 9, 2, 7, 3. These are random numbers. But what I have ensured here that it has 3 rows. Row 1, row 2 and row 3. And it has 3 columns as well. Column 1, column 2 and column 3. If I ask you about the entries of row 1, in row 1 we have 1, 2, 3. These are the members of row 1. If I see the row 2, 1, 0 and 9 are the members of row 2. 2, 7 and 3 are the members of row 3. We can also say the same thing about columns, like you can see the same component will be used now for columns as well. If I write 1, 1 and 2, these are the components of column 1. If I write 2, 0 and 7, these are the components of column 2. And 3, 9 and 3, these are the elements of column 3 or the components of column 3. Likewise, the same numbers 1, 2, 3, 109 and 273 can be determined as rows and columns, and as you've seen here, these are simple numbers, and that is how you have to understand the rows and columns. Now, as I said, the square matrix is a matrix that has equal number of rows and columns. Now, in the beginning I have said a matrix is a rectangular arrangement, and now you can understand a concept here that a square matrix is also a rectangular matrix. Is there any confusion regarding that how a square matrix is a rectangle? Then we have to go to basic geometry and let's just do it in a quick while here. See, what is a square and what is a rectangle? In a rectangle, you have all the angles 90. All the angles make 90 degree. In square also, you have all the angles 90. In a rectangle, you have opposite sides equal. In a square also, you have opposite sides equal. In fact, all the sides are equal. But in order to be a rectangle, it just needs to have the opposite side equal. Here the opposite side, if I name it as A, B, C, D, you can see AD and BC opposite equal, AB and DC opposite equal. Oh, ABCD. AB and DC equal, BC and AD equal. So these are opposite sides. Now, in order to be a rectangle, it must have all the corner angles or the vertex angle of the measure 90 degree, which it has. And here it has that same thing, same quality. Opposite sides must be equal in order to be a rectangle. It is having that quality as well. So a rectangle is there in a square. I can call it that all the squares are rectangles, but all rectangles are not squares. So we can say that a square is embedded inside a rectangular matrix, or you can say we can form square matrices with the help of rectangular matrices by excluding some elements or by taking it equal number of rows and columns. So once you have understood what is a square matrix, let's move on with the next topic. That is a very important one, yet very significant as well. Diagonal elements. I'm not saying diagonal matrix, which we have next, but first we are looking at diagonal elements of a matrix. Diagonal elements of a matrix. Like I said, diagonal elements of a matrix. Diagonal elements of a matrix. How do we understand that? Let's first take a square matrix, for example. And yes, diagonal elements are only possible in case of a special matrix, which is a square matrix. So I'll just copy down one more time. 1, 2, 3, 1, okay, 0, 1, 9, 2, 7, and 4. Let's say this matrix. Now, here we have to focus on the elements. Like if it's a square, like I'll just make a square out here. If it's a square, you can see these are the line joining the opposite vertices here, and this also. These are diagonals. This is one diagonal, this is another diagonal. These are diagonals. Now here in matrix also, we can consider, if I just make a line here like this, you can clearly see this is a diagonal. Now, there can be other diagonal possible, but when we say diagonal elements of a matrix, we only consider the leading diagonal that comes from left side to the right, left to right, and top to bottom. So, leading diagonal, left to right, top to bottom are the elements. Now, these members 1, 1, and 4 are the diagonal elements of the matrix. I'll write it here. 1, 1, and 4 are diagonal elements. These are diagonal elements. I hope it is clear. Simple. In a square matrix, yes, it is not possible in all the rectangular matrices. It is only possible in case of a square matrix. If a matrix is a square matrix, then we can have a leading diagonal, top to bottom, left to right, will be considered as, and the elements in there will be considered as diagonal elements. Now we are going to see the type of the matrix which I mentioned before explaining this diagonal elements of a matrix. Now what is a diagonal matrix? What is a diagonal matrix? Now again, a matrix, I call it a square matrix because it has to be a square matrix. A square matrix, that has only diagonal elements as a non-zero entry and rest all the elements are 0. So a square matrix that has only the diagonal elements, like I said, diagonal elements of matrix, diagonal elements as a non-zero entry and rest all the elements are 0 is said to be a diagonal matrix. I'll just give you an example here. I'm writing it here for you, like I write the number 4, 0, 0, 0, 5, 0, 0, 0 and 1, let's say. So you can clearly see that this diagonal entry is non-zero, means we have real numbers here. And rest all the entries are 0. Now this is a diagonal matrix. I think it is very clear to all of us. Now moving on next to another type of matrix which we call as scalar matrix. Scalar matrix. Again, a scalar matrix is a square matrix. A square matrix that has only diagonal elements at non-zero entry. But here there is a thing that you need to add, that as non-zero entry and rest all the elements are 0. So here what we need to change, I'll just delete this portion. It has all the diagonal elements as non-zero, same. It has to be non-zero, same entry and rest all elements are 0. This will be more clear with the example I'll write here. I said it has to be a square matrix. I could have said that it has to be a diagonal matrix, so which will satisfy the initial conditions. And now, as I said, it has non-zero, same entry. So I'll write here 4, 0, 0, 0, 4, 0, 0, 0 and 4. You can see the diagonal elements are just 4. It could be like this as well. It could be like 2, 0, 0, 0, 2, 0, 0, 0, 2. It could be like this also. So this is a scalar matrix. This again is a scalar matrix. You can see it has only the leading diagonal elements as non-zero, yet they are same. That's the difference between scalar matrix and diagonal matrix, you must remember. Moving on to the next topic, that is next type of a matrix. Again, it is similar to the ones we have just discussed. I hope this is visible to you. Identity matrix. Identity matrix. What is an identity matrix? Identity matrix has to be a scalar matrix. A scalar matrix. As I said, in order to be scalar, like in order to be a scalar matrix, it has to be diagonal. Means it has to satisfy the condition of being a diagonal matrix. And in order to be a diagonal matrix, it has to be a square matrix. Because diagonal matrices are possible only in case of square matrices. So a scalar matrix, when I say scalar matrix, the hidden meaning here is that it is a square matrix, it is a diagonal matrix, and it is a scalar matrix. So scalar I have already written, so it's square and diagonal both, that is satisfied here. A scalar matrix that has all the diagonal elements as one or unity, then that will be a identity matrix. Like I can give you an example, and for identity I am using the letter I just to make the distinction between. You can clearly see 1 0 0 0 1 0 and 0 0 1. This is identity matrix. So these are the type of matrices that you must know in order to understand the concepts that are required to solve all the questions in ICSE class 10. Now we are done with the types of matrices. Moving on, we are going to discuss about a very important concept, that is transpose of a matrix. As I said, we are going to discuss about the transpose of a matrix. Let's see here. What do I mean by transpose of a matrix? Transpose of a matrix. It's a very simple concept, yet it has tremendous application. Let's see. If in a matrix of the order n cross n, where m is number of rows and n is number of columns. So if in a matrix the order of the order m cross n, where m is the number of rows and n is the number of columns, the order is reversed. Well, I'm not writing the definition as if it would be written in the book. I'm writing as if you can understand for your convenience. This has been modified a little. So if in a matrix of the order m cross n, where m is the number of rows and n is the number of columns, the order is reversed. That is, the order is made, the order is, sorry for all this, made n cross m. Order is made n cross m. What happens then? N, which was actually the number of columns, becomes the number of rows. So n is the number of rows and m is the number of columns. Now let's see with an example. I think the words are enough to tell, but without the example, things will not be crystal clear. Let's see. I write a matrix 1 2 7 2 1 9, 0, 2, 3. I'll have to add one more for simplicity. 1, 1 and 0. So now, if I ask you what is the order of the matrix first? Okay, the order of the matrix here is 1, 2, 3, 4 rows. So it is 4 cross 1, 2 and 3. 3 columns. So it has 4 rows and 3 columns, like m rows and n columns. Now, if I do the transpose, that's denoted by A equals to this. X transpose will be denoted, I'm writing it here, as A dash or A prime, we also call it, or A and a small t on top, AT, that is A transpose. In some books, it is also written as A with a small t. It is up to the book you're following or referring to, but A dash is a standard notation. You can use A dash or AT or AT, any of the three. So what will be A transpose? I'm writing it here. You can clearly see A transpose is the transpose of the matrix. I'll write it once more. 1, 2, 0, 1, 2, 1, 2, 1, 7, 9, 3, 0. Put a dash here because we are transposing this, and after transposing it becomes like this: 1, 2, 0, 1. This column 1 becomes row 1. Column 2 will become row 2. 2, 1, 2, 1. 7, 9, 3, 0. 7, 9, 3, 0. So now you can see the order here was 4 cross 3, but here the order is 3 cross 4. Now it has 3 rows. This as first row, row 1, row 1, this is row 2, this is row 3. This is column 1, column 2, column 3 and column 4. This is self-evident here. So now we have the concept of transpose of a matrix. Next in the video we will come up with the operations in matrices. So stay tuned. We will see you in the next class, in the next video. Thanks for watching.